Hello friends, today I am going to solve LeetCode problem number 59, spiral matrix 2. This problem is quite similar to the LeetCode problem number 54, spiral matrix, that we solved yesterday. So if you could just go and look at my video for a spiral matrix, then it would be easier for you to understand this problem and try to get your own approach for this problem as well. So now let's begin with this problem. So here in this problem we are given an n by n matrix. It is a square matrix and we need to fill all of its elements from 1 to n squared in spiral order. So since it is n by n matrix, the total number of elements would be n squared. So that is why we are able to fill it from 1 to n square, and the constant given to us is n is at least 1 and maximum of 20. So now let's see how we could solve this problem. So initially we have an empty matrix of n by n. So since this is a square matrix of length 3 rows and 3 columns, so it is of 3 by 3 matrix, and we need to now fill this empty matrix with these numbers from 1 to n squared. N squared is equals to 9 here in case of 3, and in a spiral way. So spiral way means we start from the top left and then we move from left to right, and then we change our direction from top to bottom, and then we change our direction from right to left, and then we move towards the top, and then we go over. So we are now repeating the same process again and again. Okay, so now how can we solve this problem? How can we fill this matrix with these integer numbers? Okay, so for that, what are we going to do is I'm just going to tell you the optimized solution. If you would want to look at more details before you come up with the optimized solution, I suggest you that you look for a spiral matrix solution that I created yesterday, which I have added in my description below as well. So now what are we going to do is, first of all, we are just going to fill all of these cells with a value 0. Okay, so that will help us understand if the cell is already been filled or we still need to fill it, because we are filling it from values starting from 1 to n squared, right? For 1 to n squared, and so basically our target cell value will not be 0. So if it is 0, which means that we have not yet filled the cell value, right? So now what we are going to do is we start from the top left and we see that the value is equals to 0. So we take a counter c which is equals to 1 initially. So we fill this cell with the value of c. So since value is equals to 1, so we fill it with the value of c, and then we increment the c value. Now it is equals to 2. Okay, so next we move on to the next cell, and then we found the values again equals to 0. So now what we do is we fill this cell with the value of c. So we now have filled it with c, and then we update the value of c. Now it is equals to 3. Next we move on to the next cell in the same direction, and then we find that the value again is equals to 0. So we update it with the value of c, and then we update the value of c to 4. Now while we try to move to the next cell, what we found is that we are exceeding out. So how can we check that? Is we could just so we are keeping track of the cells. Okay, so track of the rows and columns. So this is 0 1 2 row column, this is 0 1, okay, this is 1, and this is the second row. Okay, so while we increase the row we get the value of 3, and then when we take the modulus of 3 with the value of n, which is equals to 3 here, then what do we get? We get the value equals to 0, right? So in that case, we know that 0 cell, our row is all still equals to 0, right? But the cell we got, column we got, is equals to 0 here. So 0 0, if you look at 0th cell, 0 row, 0th column, we see that the value is already filled here. We already have a value which is not equals to 0, which means that now it's time we change our direction. So which direction do we take? So we go down. Okay, so now we are going down, and then while we go down, we are now incrementing the value of our row, and our column will stay the same. Okay, so now we go down, we see the value is equals to 0, so we update it with the current value of c, which is equals to 4. All right, so this is 1, we update it with the value of 4, and then next we move to the next cell in the same direction, and since it is again equals to 0, okay, we need to update the value of c as well. So since it is in the same direction with the value 0, we update it with the value of 5. Now c is equals to 6. Okay, now what happens is, while we try to go to the next row in the same direction, what we see is the row which is now equals to 3 modulus of 3 becomes equals to 0, and now we find that 0th row and the column 2 is already filled, right? This is 0th row and column 2 which is already filled. So what we do is, now we change our direction. So we change our direction to right, I mean to left, from right to left. Okay, so what we are doing is, we are now decreasing by -1 the value of our column. Okay, so column is now being decreased by -1, and our row will remain the same, so we are not changing our row. So what happens now is, we change our direction, we found the value 0, so we update it with the value of c now, which is equals to 6. So we now update the value of c, which becomes equals to 7, and then we move ahead in the same direction, and then we again found a 0, we update it with 7, the current value of c, and update the value of c to 8. Okay, so this is the value of c. And then now, since we try to go to the next column, we find that we are now going to the column number -1. Okay, so now -1 modulo of 3 is equals to -1, and now what we do is, since we do not have any columns, rows -1, we are actually going to take the absolute value of this, so which will give us a column equals to 1, and in the row 2 column 1 we have already a value field, right? So that means now we need to change our direction. So now we move up and we figure out a 0, so now here we update it with the value of c. Now our c is updated again to 9, and then next step, we again try to go in this direction, right? In this direction, which means now the column is 0, row is 0, and we know that it is already being filled, so we change the direction from now left to right. So while we change our direction, we know that we find that it is value 0, so we update it with our value of c. So now this becomes equals to 9. And finally, since we have filled all the cells, we are now done with our operation, and we then return our matrix. Okay, so that is basically how we will be performing our like operation for this matrix. So what we do is, we start with the row is equals to 0 and column equals to 0. Okay, and then every time we check if the column is already filled or not. If it is already filled, we then update the direction, and then if it is equals to 0, that is if it is not filled, then we just update the value of cell with the value of c, and then keep going on that direction. Okay, so now let's move to our code and write our code. Okay, so what are we going to need is, we would need first of all a 2 by 2 matrix filled with zeros. So let matrix is equals to new array of length n, and then for let I equals to 0, I is less than n, I plus plus. So we are going to fill each of the like row with trix, okay, each of with a new array with a length and fill with the value 0. All right, so now we have created our matrix. What are we going to do is now we need rows equals to 0, column equals to 0, and then we need a direction, right? Which direction are we moving to? So we are going to create a direction array. So 0 1 means that we are traversing over from left to right, because like 0 represents the we are adding a 0 to the row, which means that the row is never changing, right? Plus we are here we are adding 1 to the column, so that means that we are incrementing the column, so that would mean we are moving from left to right. In the next direction we go from top to bottom, okay? So from top to bottom means we are incrementing the row, right? So that would be 1, and column remains the same, so it would be 0. And in the next step we change our direction from right to left, which means that we are changing our column, okay? So since we are changing our column from right to left, row would still remain the same, so that would be equals to 0, and column is decreasing, right? So that would be -1. And in the next step we change our row from bottom to top, okay, which means that we are moving from higher row to less row values, okay? So we will need to decrement the row and the column would remain the same. So this will be used to represent our direction. Initially our directions would be along the row, right? We would be increasing the column value, so that would be equals to 0 here. And now we are going to take the count, which is equals to 0, which will be used to fill in the values, okay? Now while count is less than n times n, we keep on filling our matrix. So matrix at index, okay, row and column will be equals to our value of count, and then we increment our count. And now we need to check for the next cell, is the next cell filled or not. So we are going to define a row value, and we are going to take the absolute of r plus, and then in which direction we are moving, so direction of d0, and we are going to take the modulus by n here, okay? So we need to first of all check our next step, next cell, if it is 0 or not. Similarly for column, okay? So this is our current row and this is our current column, and direction d1, in the same direction we check, and if it is, now if matrix at index next cell is not equals to 0, that is when we change the direction, right? So now direction will be equals to t plus 1, and we are going to take modulo of 4, because like the length of the direction array is equals to 4, okay? And then why are we taking modulo? Because like once we change our direction, like from one direction to another, so this is the second direction, this is the third direction, this is the fourth direction, and then we again change back to the first direction, right? So that is why we are taking the modulo operation. And now what we do is we update our row values. So now row would be equals to direction at d0, okay? So if the direction doesn't change, that it will keep moving in the same direction, else if the direction changes, then this row and column would now be the cell in the different direction. Okay, so that is all for filling, and now finally we are going to return our matrix, return our matrix. Okay, let's try to run our code and see if it works. Oh, I got some error. Okay, so we should continue until and unless it is less than or equals to n times n, right? Now let's submit this. Awesome. So let's talk about the time complexity. Yeah, so since we have a for loop here just to fill our matrix, so that is of n time complexity, and we have a while loop here, right? And the while loop is continuing from 1 to n times n, right? So the time complexity becomes O of n squared. And when we talk about the space, since we are creating a matrix, though this matrix is our resulting matrix, we do not usually count the space of the resulting matrix. But if we were to count this space also, that would be O of n squared. But if we disregard this, then that would be constant space complexity, because like this direction is only of space, like of length 4, right? It's constant length, so it would be a constant space complexity. So that's all about this solution. Let me know in the comments down below what do you think about the solution, and please don't forget to like my video and subscribe to my channel for more daily LeetCode solutions. Thank you.